Kit from the containers team here at AWS. Nathan, thank you so much. I know you're a busy guy. We're happy to have you here.
Thank you very much for having me. It has been a busy week, but very exciting.
Nathan, welcome. Always happy to have you on the show. As always, you're always a hit with the viewers and the fans, of course. But yeah, thank you for being here. Amazon ECS Anywhere. Where do we start? Can you give us the elevator pitch?
Yeah, so Amazon ECS Anywhere is really designed to further our goal of having ECS essentially be a planet scale orchestrator. So over the years, you'll see with ECS, we have expanded the range of compute that you can use. So we started out with just EC2, and then we decided to add AWS Fargate so that we could run containers without having to worry about EC2 instances. Then we have wavelength and outposts. So now with ECS Anywhere, you can bring any hardware that you want. So no matter where it is, could be physical device in your office, it could be on-premise device inside your data center, could be an IoT device somewhere, a cash register, a gas pump, any type of device could actually be orchestrated by ECS.
To add a little more clarity there for folks that may not have used ECS directly, what this basically means is that your underlying compute configuration or vector can still be controlled by a single API, and that is the ECS API. And so previously, where there may have been a smaller number of those backend compute options, people may have thought of it as just like, oh, AWS manages it with this range of management in the cloud with this configuration. But now I know Andy spoke about it at reInvent, ECS Anywhere going GA. Bring your own hardware layer and run ECS workloads on that. Is that correct?
That's correct. That's correct. And I guess I should back up a little bit and specify more, when it comes to orchestrator, what's the purpose of it? So one of the cool things about orchestrator is it separates out your application from the capacity that runs the application. So if you think about traditionally, if you had to start up your computer, you turn on your computer and then you launch an application on that specific computer. Well, with ECS, what you do is you say, I would just like to run this application, and then you can provide a pool of computers that you want to run it on. And those computers can be capacity. And the cool thing is it doesn't have to be all the same type of computer. You could have computers of different sizes. These different types of compute will become available as capacity for ECS to put applications onto in order to fill these servers or computers or whatever the capacity is, whatever the hardware device is, up with applications that are utilizing the CPU and memory on those devices. So you can essentially farm work out over fleets of devices that can actually do that work for you.
Yeah, we've certainly seen a lot of really interesting evolution in the container orchestration space, and I'd love to hear your thoughts on how this fits in, how it compares. But before we do that, you mentioned this is a planet scale a container orchestrator. Maybe I didn't use the exact right words. Maybe you could tell me a little bit about what that means to you, and then if you can share, who are the customers who are going to reach out to this first? What are the pressing problems today that they're facing that this is the best tool for?
Sure. So what that really means to me, one of the things I like about ECS that's unique about it is that it is a shared control plane. So we have a secure way for multiple people to make use of the control plane. And we essentially have one system that's keeping track of countless devices, EC2 instances, outposts, and now also potentially, ECS Anywhere hardware devices that people have added to them. And on top of that, we have countless and countless applications that people are running. And all of this is kept track of centrally. So when I compare it to other types of orchestrators, there's a lot of orchestrators out there where you run your own control plane, which is your control plane. And oftentimes these orchestrators, they aren't designed for the beginning to be shared. They aren't designed to be secure for having multiple people making use of the same control plane. So there's a lot of waste to give all these different things their own control planes. And additionally, there's a lot of building over and over again. You deploy the control plane here, you deploy the control train there, deploy it here. A lot of independent management and ops teams are required to manage these things. With ECS, what we've done is we've created one centralized control plane, which is capable of keeping track of massive amounts of infrastructure and massive numbers of applications and launch massive number of containers per second. and we centrally manage that, update that automatically behind the scenes, so that we don't have to have tons and tons of ops teams that are spinning up their own infrastructure and patching and updating it. All of that is done centralized by AWS.
Nathan, you are a great guest for a lot of reasons, but selfishly, you're going to let me say my favorite catchphrase on this show, which is undifferentiated heavy lifting. Rob's like, Nick, we've only been live for 9 minutes and you've already said it. Like, I'm going to you hit the nail on the head, right? Manual work that is done redundantly, that is not providing net new value to the business, and having that, removing that burden from teams that just want to have a control plane is something that ECS Anywhere solves. And to your point, people have fleets of mixed types of hardware. Ultimately, you don't want to have to run multiple nearly identical copies of your control plane just because you have different underlying compute. But historically, people may have had to do that. This sounds
one of my favorite. I want to say interrupt real quick. Say one of my favorite stories I hear over and over again working at AWS, and especially with ECS, is a startup that blows up overnight. They're getting 10x, 100x their users. They're trending on App Store and everything like that. And then you find out their engineering team only has like 3 people on it, or something like that. And they're managing, tremendous amounts of infrastructure they've been able to scale out to overnight, essentially, because they're using AWS managed services. And that's always just amazing to me. Like the ratio oftentimes of number of customers being served relative to number of engineers is tremendous. There's so much efficiency involved there, and it's incredible to be part of that and help enable that efficiency.
I just a funny aside, if that is your favorite example story of customers, I kind of like the other one. I think the other one's really valuable too, which is the customer builds something, and more often than not, hey, like your ideas don't work out, right? Startups are more likely to fail. And what I like about what we have here at AWS is increasingly a complete set of tools that really scale with you as you use them, right? So let's say I build Uber for dogs and nobody uses it. Surprise, surprise. Well, guess what? Because it's serverless, because it's scalable, because it's pay as you go, it's totally elastic. I'm not paying anything for my failed experiment. And that's just as valuable, the ability to rapidly experiment. Because a priori, who knows what's going to work, right? And so I think that's the other side of the coin that yes, absolutely, small team of engineers pulling off heroic feats of scalability because they're using all these managed services. But on the other side, the infrastructure and power of elasticity, experimentation, rapid iteration, it all comes in one package.
Oh, I absolutely agree with that, especially with ECS, because we have that shared control plane. We're enabling people of all different scales. So there's some tremendously large customers, and there's some customers that are only orchestrating a few containers. But we're able to essentially combine all that together into one control plane rather than having wasted control planes that are sitting there monitoring just like one container or 2 containers. We can do that.
We'll tease apart the specific like workload examples here, but we have gone 10 minutes talking about containers and orchestrators, and no one has said Kubernetes. So I'm just gonna say it. I'm the bad guy in this show. Kubernetes, what is it? How does it come into play with ECS or other container orchestrators? Because we're talking about tools that make things easier, and I know Kubernetes is supposed to do that. At least that's what people say. So Nathan, you're the containers person here. Talk to me a little bit about that.
Yeah, so I like Kubernetes, this great open source project. It has made a few different design choices that I think are different from the way we approach Amazon ECS. And the first thing that I mentioned, obviously, is the control plane model. When you think about running Kubernetes, oftentimes, even within software organizations, they end up running multiple Kubernetes control planes and multiple Kubernetes clusters because they don't really quite trust namespacing. They don't really quite trust the ability to have everything within one shared control plane. So there's a different type of model for how it works. And what Kubernetes was always traditionally super well optimized for is when you have workloads you want to deploy in multiple places, including on premise, because you would have the same API and control plane on your local device, as well as your on-premise data center, as well as in the cloud. And I think that's still true. I still think Kubernetes does this really well. I think what we've done with Amazon ECS, so we offer another alternative for folks that do want to use a container orchestration control plane from anywhere and in a variety of different places. but they don't want to have to manage Kubernetes. They don't want to have to upgrade it periodically. Like we know the Kubernetes has, 3 major releases per year, sometimes with breaking changes that you need to update various components within the cluster for it to continue to work properly. And what I found is that for many people, that's a bit of a burden. Obviously, if you have a very sophisticated technical organization that has a lot of Kubernetes experts and can keep up with that, it'll work out great for you. Totally, it's fantastic. If you are one of those organizations that wants to do more engineering with a fewer number of engineers, as I mentioned before, that scales overnight, or maybe you just have like a small project that you don't necessarily want to have to touch that thing again every 3 to 6 to maybe 9 months to upgrade a control plane. You may actually prefer Amazon ECS instead, and you can use that now locally as well as on AWS.
Yeah, I think you bring up a really good point, which is the level of technical expertise required to operate infrastructure and tools. And everything we're talking about, I think even AWS included, in all of our services, has some level of trade-off in terms of what is the learning curve, what are the core concepts, because at the end of the day, you're relying on these things to run your business, right? And so you have to understand in full depth what the implications are, how do you detect issues, how do you resolve them, how do you monitor this thing. So there's surface area any way you slice it. And I think, correct me if I'm wrong, what you're saying is, hey, look, one of the things that the team has prioritized in this case is making sure that surface area is as small as possible, as focused as possible. And I think later on, I'd love to hear more about some of the monitoring story, how this thing actually works under the covers. If you can take us through there and maybe even show us a demo. But I think that's a really good point. Right? If you have a small team, you're building a startup, you have an application. If it's just 3 or 4 engineers, you have the DBA, the back end engineer, you have the front end engineer, and the mobile engineer. That's 4 people. Do you really have room and budget for a Kubernetes infra engineer? I don't know, right? A lot of companies, that's a tall ask. And by the way, I'm not knocking Kubernetes. I agree with you. I think it's a perfect characterization. It's a great tool for the job. It's a slightly different job though. And I think that's the really good way to think about it. Is like I think the best job we can do here on this show and elsewhere on our AWS is making sure that customers understand what is this tool for, what is it best at, because we've never said this is the tool for everything. Nothing is the tool for everything.
Yeah, and I definitely think there are some pieces of software that are really optimized for Kubernetes. And if you want to use that particular piece of software, you basically need to use Kubernetes. What I would say that Amazon ECS excels at is running your application in a way where you can use lots of fully managed services, and you want to focus more on writing your application code than building an entire infrastructure platform to support running your code.
One of the things that you touched on is the ability to run. It's called ECS Anywhere. It's in the name. You run anything, anywhere. And I'm immediately jumping to the biggest use case that I'm aware of for this is hybrid environments that span cloud and on-prem. What's the deal with on-prem? Why are on-prem containers so important?
So in many cases, there are workloads which have a certain amount of data gravity to them. So perhaps there is governmental regulations around where data should be stored. Perhaps there's just a tremendous amount of petabytes of data in some on-premise data center, and you can't move that around as easily. In many cases, also, there is hardware that's been bought and paid for, and it still has a significant amount of lifetime to it, and you still want to make use of that hardware. So there's a variety of reasons why folks like the cloud and maybe even be using the cloud, but they still have things on premises. And what we find is that they want a consolidated interface for helping manage all these resources in a way that's familiar and usable for their engineers.
Yeah, and this makes sense at a lot of levels, right? Even just from the time to learn tooling, previously ECS as an AWS service and the SDK and the tool chain there was, if you wanted to run similar types of containerized workloads, you're using a tool that is not ECS to run that. So you're moving from one to at least two tools to do that. Now you can consolidate on that developer experience, but even more so, which I'm excited to see later, is the ability to centralize the management in like in the AWS console. You will be able to see, well, you can today if you're using ECS Anywhere, your hosts that could be on premises that are running ECS Anywhere directly in line, just as you would any of the other number of cloud-based hosts or an AWS Outpost, for example. So I'm excited to see that. I think talking about sort of how this works under the hood is a pretty important topic here, because anytime we're branching from the cloud to something that's on premises, and then, oh, by the way, they talk and they have interop really easily. My first question is how. Is there any diagrams or anything you can walk us through so that we can see a little bit more about that?
Okay, yeah. So let me see if I can share my screen. And bringing up the screen share, let's go over to a blog post I published recently. And there is a diagram here showing the components that go into Amazon ECS Anywhere. And there's basically two components that need to be added to your device, your hardware device, in order to turn it into a managed instance for ECS Anywhere. And the first one is AWS Systems Manager agent. And so this agent is really the foundation that turns a piece of hardware into what we're calling a managed instance. And if you think about like an EC2 instance in the cloud, there's various capabilities that it has. One of the important ones is the ability to assign an identity and access management role to that instance. And what that does is it essentially automatically puts AWS credentials onto that instance so that it can make calls to other AWS services. Most often, if you're running an application directly on a host, you're going to add to that role something like, I need to be able to talk to S3, I need to be able to talk to DynamoDB, certain levels of permission that you actually need for your application to function. And so traditionally, that was not easy to do for on-premise instances. You needed some way to get credentials onto these machines. And if you didn't do it right, you would end up with these long-lived credentials that would sit on the instance, for a long period of time without being rotated. And that's not ideal because, you don't necessarily want to fully trust the software on your box, and perhaps some of it has a vulnerability. Maybe somebody gets access to that instance and they grab the credentials off of that instance for some reason. That would definitely not be ideal if those credentials are long-lived, because now they have, or even more importantly, if those credentials are shared across like whole fleet of instances, because now they have access to who knows what for who knows how long before you notice and actually revoke those credentials. So one of the things that is amazing about the fully managed IAM role is that it rotates automatically. And so with Systems Manager Agent, we've extended that capability to your own devices. You install the SSM agent and you use an activation code to actually set up a private identity and a key for that particular device, which you can use to get IAM credentials and rotate them automatically by default every 6 hours. And so these devices have an IAM role, which then allows them to talk to other services. And one of those services that it can talk to with the right role is actually Amazon Elastic Container Service. So we took the Systems Manager agent and built on top of that modifications to our existing ECS agent to allow it to exist in this environment with a role that allows it to talk to the ECS control plane. And in both cases, with the Systems Manager agent and with the ECS agent, the way it works is it opens a control channel back to the AWS control plane in region. And it keeps that open so that it can send commands down. So what that allows us to do is, even if your device doesn't have a public IP address that's inside a private network somewhere, it's behind a NAT gateway that is basically taking one public IP address and splitting it out into a bunch of private IP addresses in the network, we can communicate back down over that control channel to either the SSM agent or to the ECS agent to control that machine and do certain tasks on it, such as for the SSM, maybe updating the machine, opening a session so I can connect to it and send commands to it, or for ECS purposes, launching tasks and containers on that device. And then obviously these devices, they will also report back with logs and metrics and other various things that you would traditionally be used to with ECS.
This is
you covered a
go
couple of. Go ahead.
I was gonna say this is fascinating, and this is as soon as you started diving deep on that, that's where the questions have started pouring in. I'll try to make them quick. There's two in particular. First of which is involving sort of like the accessibility of the data on the managed instance. Can a customer use like Direct Connect to connect to an ECS container that's on a self-managed instance if it has ECS Anywhere installed?
So Direct Connect is basically a way to have a managed internet connection between like AWS region in your on-premise data center. So yes, you can do that. You don't necessarily need to do that though. So I mentioned earlier about SSM and being able to connect back over that control channel. So I can actually open a SSH or a shell session to one of my devices, even though it's on the local network, even without Direct Connect. I don't even need any VPN gateway or anything like that. Obviously, if I do have that Direct Connect connection, I'll have a higher bandwidth, higher fidelity, more reliable connection from my data center to the AWS region, but it's not by any means required.
Awesome. And then one other question from Twitch chat was I think it's largely what you described, but they're just sort of playing it back to make sure that they can understand this correctly. They're wondering, can they install the SSM agent to an on-prem machine, which enables it to assume an IAM role and interact with AWS resources as if it was on a VPC? So I know they didn't mention ECS Anywhere here. It's a bit of a more generalizable SSM question, but any thoughts there?
Yeah, so that's exactly how it works. So once you have credentials, you can assume that role, and if that role is a role that allows you to communicate to AWS services, you'll be able to talk to the AWS APIs. Now, obviously, most of the AWS APIs for serverless style products, like let's say like SQS, SNS, DynamoDB, these serverless services, they have an API endpoint that you can talk to. And so your device, as long as it has internet access and it has the IAM role, which is giving it credentials, it can communicate over the internet to that API endpoint and use that AWS service. Now, there are some AWS services like RDS or load balancing, which live within a VPC. And if you are living within a VPC inside private subnet, so it doesn't have a public IP address, then you need to do a little bit more work to actually connect to that, because your private network and the remote AWS private network, well, they're both private. So they don't, by default, they won't have any connection to each other to be able to talk. So that's where you need a little bit more networking infrastructure there. That's where Direct Connect could come in. And that's where AWS site-to-site VPNs come in, which allow two private networks to actually communicate with each other over the internet securely.
I am itching to see a demo of how all this comes together. You've been talking about how I can run any device anywhere. I wonder what that actually means. Is there any way you can show us something hands-on?
All right. Yes. So let me bring this up. I do in fact have an ECS cluster here, and it is a ECS cluster that has devices inside of it, which are external. So first I'll show this process of how I would actually go about registering my devices into an ECS Anywhere cluster. So every ECS cluster is automatically enabled with ECS Anywhere. I don't have to do anything special here. All I have to do is literally click register external instances. So if you're looking for this feature afterward inside the console, just go to ECS, create a cluster or one of your existing clusters, and then click this register external instance button. So the first thing you do is specify duration. So this is how long you expect it to take to actually go through to each of your devices you're registering and activate them. Obviously, if you put a duration here too long, the activation key will remain active for that amount of time. And then you can also put another further limit for how many times the activation key can be used. So here, I'm taking the defaults of, for 1 day, within the next 1 day, I can activate one instance and give it this ECS external instance role. So once I do that, it's going to give me a command to run. And that command is basically all that it takes to register that device as capacity inside of my ECS cluster. I'm not actually going to run this command live because it does have some activation secrets in it. I don't want people to be able to register their device into my cluster and make my demo kind of complicated.
What are you talking about, Nathan?
What I will do.
That's a great demo. Just give out the access key to everyone in Twitch chat, and you'll see in real time as everyone's personal computers join your ECS cluster. That's an amazing demo.
Pretty interesting. I'll just put in like 100 activations for like 30 days and see how many people's devices, and then I'll do some Bitcoin mining on them.
So,
to actually, what I want to just do is I want to register my own devices. So let me show you the devices that I've registered here. This is a small Raspberry Pi cluster that I've put together with 4 Raspberry Pis, providing a total of 16 CPU cores and 32 gigabytes of memory. And so I can actually use this cluster now as capacity for my ECS cluster and run tasks and services on that cluster.
So while we're looking at the the cluster over there, I saw in that curl command that wasn't using like the AWS CLI or anything. I would, you on that cluster, you'd basically, like SSH into the cluster, or you directly are just accessing it. And you just run that curl command, and that, like, with no other installation sort of out of the box, enables you to register as an agent or register as a host for the ECS cluster.
So the way it works is it does a little bit of discovery to figure out what architecture you're running. So we really want this to run across Intel and ARM. We want to run across a variety of different operating systems. So it does a little bit of discovery first of what operating system you're running and what device architecture. And then it goes out and finds the appropriate software packages to install for the SSM agent and the ECS agent. And then does that activation and install process for you automatically. So fully automated. You don't have to do anything else. It just goes ahead and installs everything, and then once it's done, you literally refresh over here in the console, and you see your instance showing up as an external instance here. True.
That is so slick. I mean, this is one of those things that strikes me as this is duh. Why didn't we do this sooner?
So let me show you one of the cool features that I really like. So normally, if I was to click on this instance ID here and it was EC2 instance, it would take me to the EC2 console. But now if I click on it, it takes me instead to AWS Systems Manager, Fleet Manager. And this is where I can see details about my remotely managed instances. I can even browse the file system, user, and groups and look at some basic performance stats. But rather than showing that right now, what I want to show is one of my favorite features, which is the ability to start a session and actually connect to the device. So here I will start a session, and what this does is it opens up a shell on the actual device. So I can look at my my file system here. I can even run htop, and I can see the processes running on this machine. And all of this is just from the AWS console. So I didn't even have to open up my terminal. I didn't have to create an SSH tunnel to access this because I mentioned earlier about how there's this control channel that connects back to the control plane. This device, here, this Raspberry Pi is running in my local network. It does not have a public IP. I didn't have open up any firewall access inside my router or anything like that. That device actually opened a channel out to the internet, over the internet, to the control plane, and we opened a secure connection encrypted by KMS back over that channel down to the instance. So I can access this from anywhere. I could be on the road. I could leave my devices here at home, and I can actually access them over this control channel from anywhere that I can access the internet in the AWS console.
That is fantastic. The gears are already turning in my head. The fact that it's a link, and the fact that people love clicking on links is already giving me so many ideas. Right after this, I'm going to go to Twitter and I'm going to say, hey, I've been trying to reach you about your car's extended warranty. Just click on this link.
Do some social engineering.
Yeah. Love extending their warranties. So I don't know what the problem is. Now, Nathan, I have one question here.
Yeah.
Let's say I want to use this with EC2 spot instances. How would that work?
So EC2 Spot instances are already have like a more native integration with ECS. So I don't think you would necessarily use ECS Anywhere for that purpose. Instead, you would use a more native integration with Spot instances, because ECS will then have the ability. There's some examples in the documentation for having a spot notification spot termination notification follower, basically, where when it sees that the spot instance is about to be terminated, like you lost the bid, it's going to shut down any containers gracefully on that machine, and then they'll be able to start it elsewhere. So I wouldn't say ECS Anywhere is really designed for Spot. We have other integrations for Spot. Each of these different compute types, we try to be optimized for that particular compute type, and Spot is a little different, I would say, for ECS Anywhere.
Awesome, thanks.
I have a bit of a silly
So
question.
I guess
I have a bit of a silly question, but it has a real question sort of at the end of it. I want to go and take like all of the old phones that I have and make my own ECS fleet host fleet. That's the silly question. Like, can I go and do that? And the more serious question is like, which operating systems or environments or types of devices are supported by this? Like, can I go out and like run ECS Anywhere on the traffic cam that's like right outside my apartment or something, right? Like, what is the limit to what is capable here?
That's a good question. I would say as long as you can get a shell and it has an operating system that's fairly mainstream. We do have it in the documentation. Let me see if I can find it. ECS Anywhere docs supported OS. We have a list somewhere.
Right here, Nathan teaching us how to Google.
I can't find it off the top of my head, but definitely
no worries.
Google this. I don't want to spend much time here Googling it, but there is an exhaustive list that we have published of the different operating systems we've tested it on. Now, that doesn't necessarily mean that it won't work on another operating system. It just means that we don't necessarily have a package manager for that operating system that we can pull from to install. So you could theoretically, as long as it's the right architecture, get the agent off of a different operating systems package manager, get it to your device in some way and install it. You can actually look at the source code for that script that I mentioned earlier, and what it does is fairly straightforward. It's nothing that you couldn't replicate on a wide range of different devices.
Awesome. Thank you for humoring me.
Okay, so I guess there's one more thing I should show just to verify that this works as well. I want to launch a service on the cluster. So actually, in this case, I already have a few services running. I'm going to launch one more of them, and I'm going to launch the external launch type. So there's a new external launch type. I'm going to launch an Nginx service and name it Nginx replica. I want to launch 2 of them, and I'm going to click next up, next, and create service. And so what we'll see is it doesn't take very long, but instantly, like, we have pending service. So my Raspberry Pis right now are pulling down the container image and starting it up, and it's actually already running. So now if I go back over to Systems Manager, Fleet Manager, and select one of my instances, I need to select the right one because one of them is actually filled up with containers right now. And so I couldn't actually launch anything on that one. So it's only 2 of them are actually running the Nginx. I believe it is this one right here. we'll see if I was lucky here. So if I run sudo docker ps, and yeah, sure enough, I see an Nginx was actually launched onto this machine. And if I curl localhost port 80, I actually get the Nginx welcome to Nginx page. So one more level of interestingness to this demo is for my services that are actually already running, what I did was I set up a VPN between my in-cloud VPC and my home network so that I could have a cloud-hosted load balancer, which actually sends traffic to my Raspberry Pi cluster. So here's the address right here. I don't know if it's possible to copy and paste this anywhere, but you can actually hit this right now from the public internet, and you're sending traffic to an AWS VPC network load balancer, and then from the VPN network over the VPN to my home network and hitting the Raspberry Pis here. So feel free to send some traffic to my desk right now, basically, the Nathan Peck desk region. I have actually tested this to make sure that we could have a lot of people sending traffic down here and it won't actually DDoS my home internet. So this should be interesting a test and make sure that my assumptions are correct. But yeah, so this was a really fun experiment to set up and actually hosting a website from my home network using these Raspberry Pi devices.
Now, so just one quick question here with the Elastic load balancer there. That sounds like it was not managed and deployed within ECS, right? That's just separately that you set that up with the VPN.
Correct. Load balancer was launched separately inside of the AWS console.
And is that kind of the canonical way that you recommend customers do it, or is this something that we can kind of fold into?
So there's a wide range of different ways that you could manage load balancing, and I find some people are interested in creating a sort of an API gateway or load balancer which runs in the region because they know it's scalable and it sends traffic back to their on-premise data center. The downside of that is you're going to pay some ingress and egress data charges, and potentially there's going to be a lot more network communication back and forth. Other people prefer to do their load balancing in their on-premise actually, and send traffic directly to their on-premise data center and maybe have the on-premise data center talk back to the cloud. It really depends on your application architecture and how you want to build it. There is one thing I want to demo before we run out of time, and that is the fact that when I am actually running this container on premise inside my Raspberry Pi cluster, I get the same metrics and logs that I would if it was on EC2 instance. So I can see my CPU utilization, I can see my access logs for my service, including the fact that people are attempting to basically continuously crawl my service and look for vulnerabilities with PHP my admin. So I basically need to put the AWS firewall, or what's the other service? I forget its name right now.
WAF, Web Application Firewall.
Yeah, Web Application Firewall. That's the one I need. So this is what it looks like when you don't have Web Application Firewall installed. You get continuous bots attempting to hit MySQL Manager, PHP MyAdmin, all this like old software that has vulnerabilities. Is trying to find that software and execute vulnerabilities within it. Obviously, I'm not running in that software, but the bot doesn't know that. It's still attempting.
Wait, Rob, I think you're muted, actually. Maybe.
What's that?
Oh, I think you were muted. You were saying something.
Oh yeah. I was just saying this is how you know it's real, right? I don't think Nathan would have gone in here and scripted a bot that crawls for PHP MyAdmin over here.
Well, you can literally see over here every time it happens. Like the bots come in and put a little spike of CPU every time they go and crawl. So this is one of the many fun things you see time and time again as you run a service on the internet.
Yeah, this is awesome. Thanks, Nathan. This demo to me is totally eye-opening. It's a small thing, right? I think it takes somebody who really struggles with this, has to switch through different control planes. Critical data is scattered across, this silo over here and this silo over here for this region over here. And if you think about what it takes to overcome that, that's a lot of institutional knowledge. That's a brain, that's a doc, that's a run book, that's it's just so much stuff to get that consolidated. Whereas automation can just make that not a problem from day one. I think that's incredibly valuable and underappreciated. And for people who are starting off like this, wow, kudos, right? They haven't had to deal with the how painful it is to have this kind of information.
Yeah, the way I think about it, like if you are managing your own on-premise hardware, you probably are going to have enough things to worry about with heating and power and cooling, and all the other things. Having a good network, all those things are things you need to worry about if you have an on-premise data center, which you don't have to worry about in the cloud, obviously. But if you're going to manage all those things, like, why also add the software complexity on top of all of that as well. So now I can use the ECS control plane. It's super simple to actually manage all these devices from the AWS console.
Yeah, awesome. I'm going to go and try all of my backwoods hardware configurations to try and get ECS Anywhere running on them. But obviously, we spoke about Kubernetes before. For folks that like this model, but that are running Kubernetes, EKS Anywhere, I know, also announced side by side with ECS Anywhere at reInvent. Sounds like that's on the horizon as well. Nathan, for folks that want to get started with ECS Anywhere, where should they go? And this is a hint to plug the blog post that you were showing before.
yeah. So there is a blog post that I published. Maybe we can drop a link in the chat. But it's really it's around building your own home lab. So I have a parts list for the Raspberry Pi cluster that I just showed on video, and some setup instructions for how I could set this up and configured it. And really, if you want to get started, you can do so just by going to the ECS console, creating a cluster, and clicking that register external instances button, the same one I showed in the demo. That's really all it takes. It's not a particularly complicated process. All you gotta do is click into the console. Enabled for everyone.
Awesome. Again, ECS Anywhere available as generally available now. Launched just yesterday. So Nathan, thank you again. I know you're a busy guy, so we appreciate taking the time to talk with us and to talk with the customers. I know there's tons of questions in chat. We only got to answer a handful of them, but thank you again.